Okay, so when we deal with stoichiometry for the solutions unit, mostly the questions that are different will be ones that involve ionic compounds. So the other type of question where you just do stoichiometry, like how much reactant do you have, how much product do you get produced, are exactly the same as the last unit. So the last example we're going to do is just like we did before, except maybe you have to use concentration and volume to find moles instead of mass, okay? The first couple of examples have to do with ionic compounds dissociating or dissolving in water. So we're going to, this slide just helps to remind us about dissolving an ionic compound. So because we can find concentration, which is based on moles, then we can do stoichiometry. And there is a really wide variety of questions that you could get for this topic. So moving like into grade 12, when we do concentration more than mass, then you're going to do use this lesson all the time. Okay, so the questions listed on the note page, I haven't done, none of them are limiting reagent, but you could even do limiting reagent with this. So in the solutions, there are more questions because I've included the limiting reagent question. You don't need to do those. You can just focus what's on the note, okay? So if you dissolve an ionic compound, then you're going to form an aqueous solution when it's dissolved in water, which is, of course, what ionic compounds dissolve in. And we call that dissociation, or they dissociate into ions. So when we are looking at how a solid behaves in water, in the past we wrote net ionic equations to show how the solid is formed. But now if we're trying to look at amounts instead of just saying soluble or insoluble, what we're going to do is write dissociation equations. So find your highlighter. This third bullet is the general form, and the first two describe it in words. So what you're going to do is when you're asked to write a dissociation equation, so it'll say write a dissociation equation for sodium chloride, copper 2 sulfate, whatever, then you always put the solid on the reactant side or the left, and then the ions it dissociates into go on the right-hand side. When we write the formula, we put the metal first and the non-metal second, or the polyatomic ion. So normally, because you're going to be given the solids formula, people just go in order. So they'll put the cation first and the anion second. When we did net ionic equations, I really encouraged you guys to put the charge, to put aqueous and solid, and one of the reasons is what we're going to do today, okay? So when something is dissolved in water, we're going to use AQ as its state. We do not include water in the dissociation equation. We're just going to put the state for the ions as AQ. Okay, so the ions are going to be AQ. And if you remember the weird sort of coefficient-y thing we had to do with net ionic equations to balance them, we're going to do the same thing here. So this general form, solid makes cation and anion, is fine. You could even simplify it further that the solid always goes on the left or the reactant side, and the aqueous ions are going to be on the right or the product side. It's like we're saying this solid, we put it in water, what does it make? It makes ions, okay? So you could be asked just to write dissociation equations, not do any Stoich yet. So I'll give you the formula for the solid. It goes on the left. Okay? And then you're going to split it apart into ions. So you kind of have to decide for yourself here. Say this polyatomic ion, if you struggle with those, then maybe you want to put brackets and stuff like that. So whatever sort of tricks you used for yourself when we did naming, you might need those here too, okay? Which is fine. But I will give you the solid. So when you have simple ones, like binary ones, we call them BaO, PbI2, then the first thing has to be the cation or the metal. And then the second thing is oxygen. I chose barium oxide on purpose because oxygen, we beat to death that it's diatomic. That's only when it's by itself, okay? We are talking about ions when we do this. So that's why when we did net ionic, I said it was so important to write the AQ because oxygen's natural state is a gas. This is not oxygen gas, so it does not get a little 2 down here, okay? If you want, I encouraged you to write the charges at the top. This, I said you didn't have to do. This emphasizes further that it's an ion, not its natural state. Okay, so that is a little bit weird there. Same thing with this one. I chose lead 2 iodide on purpose. Okay, so the metal is no problem. But then again, how did we deal with this? So iodine, aqueous, that is not its natural state. What did we do with that too? We wrote it out front. So ions are not diatomic. So I'm kind of out of room here, but if you want to reiterate for yourself, how do you know if something is an ion? It's going to be labeled AQ, okay? The AQ substances are not diatomic. So same thing with polyatomic ions. Again, the tricks you would have used before, that sulfate is a polyatomic ion. It does not come apart. So if you were a bracket person and you want to still be a bracket person, that's fine. You can have, for the cation, you can have a coefficient as well. That's fine. Different color. And then SO4 stays together. So just like we did before, the charges, like the barium 2+, it helps to emphasize that it's an ion, but it doesn't count for balancing or even molecular weight like we did in the last unit. So if you want to leave those out, that's fine, but make sure you put S for solid and AQ for the ions, remembering that ions are not diatomic. We're not talking about oxygen gas or iodine gas. Like we're talking about it's already gained electrons, it's its ion form. This can be very tricky to remember. Even in grade 12, lots of times students will make mistakes because we've spent so much time trying to get you guys to remember the diatomics. Okay, so questions could be like this: write the dissociation equation, and then we can use the dissociation equation to do stoic. We can treat them like a balanced chemical equation. So if I want you to do solution stoichiometry using a dissociation equation, I wouldn't just give you B like this, okay? So part A would always be write the dissociation equation, which we already did, but we can do it again. So you get the formula for the solid. We have 2 sodiums. And 1 SO4. And when you write dissociation equations, because on the periodic table, we're talking about ionic compounds, right? Which have to follow the rules. So like column 1 is a charge of 1, column 2 is a charge of 2, column 3 is a charge of 3. That's really it. It's either going to be 1, 2, or 3 for the coefficients. So these dissociation equations are often very, very simple, okay? So even plenty of them will just be 1 and 1, okay? So if you think about what would Mrs. Todd ask me, how does she know that I know how to do stoichiometry? Then that means that probably I want you to do one that has a coefficient, right? So then you can kind of think, ooh, did I balance this right? If you read this question, it gives us the concentration of Na2SO4, and it asks for the sodium ions. Why did I choose sodium? Because it has a 2, okay? So these questions, it's tricky to think about this dissociation equation, but then the math part itself is actually pretty straightforward and also pretty easy to predict. There isn't a lot of variety in these dissociation equations because there's only 1, 2, or 3 as possible charges for the cation, which limits like what kind of different things you can crisscross, because ionic compounds always follow the rules. So you can do a couple things here. Because you're in grade 11 and we first have just learned about stoic, I encourage you to not, I think in grade 12, sometimes I call it cheating at stoic. I encourage you not to streamline your stoichiometry process. However, what I'll do the example using the stoic ratio like we would have done before, and then you might be able to see, again, because it's so simple, how it works, okay? So we're given the concentration of Na2SO4 is 0.45. So that is molar, so we can use that in our ratio, okay? So we're going to build a ratio similar to the last unit. We're given the concentration of one thing, and we're asked for the concentration of something else. So when you convert between values, that means you have to do stoic. So if you want to write that down for yourself, you can. So we can do the same thing. What did we ask for? Sodium. So that's our X. What are we given? What goes in the bottom? The coefficient. So that's why, again, even though the coefficients will always be simple, then I'm probably not going to ask you about SO4 because it has a coefficient of 1, and that's the same. Okay? Not that I want to be tricky, but I also want to be able to tell that you know how to do this. And then decide how you like to solve for these. Are you a cross multiplier? Do you like to do inverse operations? Because this one's so simple, maybe it's good to do inverse operations. 0.45 divided by 1, it's just 0.45. And then you're just multiplying by 2. What we're going to do next year is take these concentrations and actually look at reversibility in the reactions. We're going to do something else with them. So the stoic part of it is often like, it's kind of like the bottom of the pyramid, the fundamental, and people will just be like, oh yeah, that's what it is. And what you'll notice when you start to do all these questions is that the coefficient of the solid, even in forever, is always going to be 1. So whatever this is, because it's always 1, then again, you can kind of streamline the stoic process. And then if this is a 2, all you're going to do is multiply by 2. Now, in grade 11, maybe you don't want to take that shortcut because you don't want to screw yourself up. But when we get to grade 12, you're going to see, oh, every single time the solid coefficient is 1, that means it's going to be over 1 or divide by 1, which doesn't change the number. All we have to do is multiply by whatever this coefficient is. So if this is 1 and this is 1, then they're the same. Not that the question asks for sulfate, but I could. But so the black part is just kind of cheating a little bit, okay? If you don't want to cheat, do the ratio every time. And then the questions can be a little bit trickier. So the next one, we're going to do a dissociation equation, but we're also going to incorporate grams. So then there's a little bit more work to that. So maybe you don't want to cheat at stoic. Okay, so for the next example, it says calculate the concentration of chloride ions in a 26.5 gram sample of calcium chloride. So now we have to incorporate grams as well, but that's okay, we know how to do that. Dissolved in 150 milliliters of water to make a solution. So this question doesn't, like I said, this would be like part B. Part A, if you needed a dissociation equation, I would write part A, write the dissociation equation. So what I'm going to do here, I'm going to write steps, And then I'll write the work if you want to organize your question like that. So again, so later on when you go to do a question like this, you'll know where the numbers came from. But you don't have to. Okay, so in this question, we need a dissociation equation because we're changing calcium chloride into chloride ions, but I won't make you guess that. I would ask for the dissociation equation. You would get marks for it, okay? So I do give you what the solid is. And you just have to split it apart. And paying attention to the two. All right, so ions are not diatomic. And this is going to impact the math, right? And again, I gave you grams of calcium chloride, and I asked you about the chloride ions. Why did I pick chloride and not calcium? Because the chloride has a 2, okay? So similar to the last unit, you're given grams. We can't compare grams. What do we always do first? Find moles, okay? So we're going to do the same thing. If you liked the way we did things last time, you can do it the same way. We're given 26.5 grams of calcium chloride. What's its molecular weight or molar mass? And then find the moles. Similar to what we've been doing, you decide how much work you need to show. You can write it all out. Maybe you like the chart, you can write it right in the chart. Same thing with the moles. When you use this, then it was just mass over molar mass gives you moles, or you can write it out. So in the last unit, when you were asked about a product, given a reactant, then you always had to do stoich to convert between them. So it's the same thing. You can think about it the same way. Oops, we're going to do chlorine, sorry. You can think of the solid as the reactant and the two ions as the products. That's another thing too, because it's always following the rules plus and minus. There will only ever be two products, a cation or positive ion and a negative ion. That's it. Why did I choose chloride? Because that's what the question says, okay? So I could have chosen calcium to find the concentration of, but again, the calcium has a coefficient of 1. Maybe that's a little bit too easy. So when you do the stoic ratio with the chloride, then it has a coefficient of 2. Sorry, I'm squishing. So 2.239 moles of calcium chloride. Its coefficient is 1. And it always will be 1. Okay, the solid always is 1. Once you have moles of the substance, you just want to read the question carefully. I could ask you to change it back into grams. In this case, it asks for concentration. Maybe it just wants you to find the moles and you would be done. So once you do the stoic part, there's a variety of things you could be asked. But it does say concentration. Like the next example, we're going to do moles, but then back to mass. Okay, so you just have to read the question carefully. The last step might not always be the same. Okay? Try to write it in different color because I'm kind of squishing. And then volume is in milliliters. So again, you have to decide, lots of people will be like, oh, I just have to move it 3 decimal places, divide by 1,000. Sometimes they'll just write the answer right in the formula. That's totally fine. Or if you want to show your work, you can. Okay? So 3.19 moles per liter. Make sure your answer has units. Okay, so the questions kind of go in order. There's dissociation equations, then the second set are more like moles and concentration, and then the last one has to do kind of more like this. So we're given a normal reaction that makes a precipitate. So it says 25 milliliters of sodium sulfide. That's this one. And its concentration is 0.085. Is added to excess mercury nitrate. So again, if you want, to challenge yourself, yes, there are questions with limiting reagent, but not in our homework listed there. What mass of sodium nitrate produces? Precipitate, sorry. So this one is the one that we're looking for in terms of grams. So now we're actually combining both. But the basic principle is still the same. If you are given information about one substance and you have to convert it into something else, you're going to use stoich, which means that you need moles. Okay? So when you find moles using the triangle from this unit, you can use the triangle, or if you prefer the formula, it doesn't matter. N is C times V. Even if you forget, the units for concentration tell you that it has to be liters. So you could have done that up here. Or you can just write it in the formula. I would accept that as well. So again, now we have moles, so we can convert between whatever we want. So I chose sodium nitrate because that's what the question says. Now, I even cheated. Nitrates are always soluble. This would never be a solid. Why did I do that? So we could use the coefficient of 2. Okay, so if this was a test or whatever, I really want you to be able to show me that you know how to do Stoic. Okay, when you do these Stoic of Solutions questions, because it's ionic compounds and stuff, again, the coefficients will always be pretty simple. So what is it? What do we want? Sodium nitrate. What's its coefficient? 2. We have the moles of sodium sulfide. What's its coefficient? Only 1. And then the same thing as last time, just double check. Do I want my final answer to be concentration? Do I want the final answer to just be moles? What does the question say? It asks for mass. I'm not gonna, I obviously have to squish, but bless you. But again, maybe you're so used to doing the molecular weight that you do not need to show that work anymore, and that's okay. Sorry, this is multiplying. Okay, so a variety of different types of questions that you can do.